Hi, today we're looking at the first fundamental theorem of calculus. Now we may recall what the FTC says is that the area under a curve, remember this is area, from A to B is equal to the change in the y values. Now this is very important for us. That's delta y. So the area equals a change in our y values. Now this can help us solve all sorts of problems in calculus. Because, for example, let's take a look down here. Let the area under the curve from 1 to 3 of some derivative equal 4. And we know the value at 1 is 3. So they give us some sort of initial value here. The initial value there is 3, and we want to find the value at the end, so 3. I can use the FTC to solve for 3 here. So if I rewrite this one, I'm going to get the area from 1 to 3 of f prime of x dx. Whoops, we got my dx up here too. And that's going to become f of 3 minus f of 1. That's just our fundamental theorem from earlier. Now, we're told what this is equal to. It's 4. Remember, this is my change in my y values. If we think of it that way, it's pretty easy to do. We get f of 3 minus, and at 1 we're told that was 3. Now, if we think about this, if this is my change in my y values from 1 to 3, I'm starting at 3, we change it by 4, we should end up at 7. And exactly that's what we do. If we add the 3 to both sides, we get f of 3 is 7. So we get so I know where I start from at 3, and this is where we ended up at. And this is, like he said, this is kind of very much related to displacement, which we're going to see again later on. Now, we don't only see it in problems like this, we only see it in more complicated ways. For example, let's say we have the derivative of a function equals 3x squared plus 4x minus 5. And we're told that the value at 2 is negative 1, and we want to find the value at 3. Now we can solve this by using an initial value problem by taking the antiderivative, solving for c, and then plugging it in. But let's see if we can apply the same method using our method up here. My rule says, well, I'm given a derivative, that's what this is, that's my derivative, and I'm looking to find a value. So if we're given a derivative and we want to find the value, our rule says take the antiderivative. It's like solving an equation, like the opposite of addition and subtraction. The opposite of a derivative is an antiderivative. So I take the antiderivative of 3x squared plus 4x minus 5, don't forget the dx, and I'm going to integrate that from, well, I'm starting at 2, I'm ending at 3, so from 2 to 3. And according to my FTC, this will equal f of 3 minus f of 2. Integrating, we get x cubed plus 2x squared minus 5x from 2 to 3. And again, that's going to equal f of 3 minus f of 2. Oh no, what happened there? I was doing so well. Okay, focus again. Okay, so if I use the FTC now, minus equals f of 3 minus f of 2. If I plug this in, we get 27 plus 18 minus 15, and plug in the 2, we get 8 plus 8 minus 10. And if I simplify all of this, this becomes 24. You can verify that in a calculator if you want to. Equal to f of 3 minus f of 2. So what this is saying is that between 2 and 3, our function has increased. The function increased by 24 units. Now how do we know it's increasing? Because it's positive. Well, we started at negative 1. So if I plug this into my equation now, f of 3 minus a negative 1, it tells me where I ended up at. Well, we increased by 24. We started at negative 1. We should be at 23, and we do get that answer right there. Now, of course, that's a very long and complicated way to solve this. There are other ways to do this one easier. For example, if I could take this to derivative and solve for c, we don't have to use this method. But there are some functions that have no antiderivative. And let's take a look at one where we really like this method right here. And it is this one. Let's take a look at the antiderivative of sine of 2, sorry, not that one. the antiderivative of sine of x squared dx. And let's say we know f of 1, let's just say f of 1 equals 5, and I want to find f of 3. Well, the problem is this function has no antiderivative. You can try to use substitution. It won't work. So what we have to do is we're going to use the FTC, the first FTC. And what it says to do, take the antiderivative from 1 to 3 of sine of x squared dx. And that's going to equal f of 3 minus f of 1. Now for this one, since it has no antiderivative, we're going to use our calculator. And let's go ahead and grab, so if I grab my trusty dusty calculator, I type it in, I'm going to go math 9, and if I type this in, I'm going to go sine, I have an old-fashioned calculator, you have to forgive me, comma x, comma 1, comma 3. And what I get 0.463, and that's going to equal f of 3 minus 5, so I know what that is. So the value at 3 is going to become 5.463. So it's telling me how much it's increased by. If you think of it in terms of like a function, like right here, if I look at the function, I don't know what the function looks like, but between 1 and 3, right, delta x is 2. I'm starting at 5. What I'm looking to find here is my delta y. Well, my delta y is just 4.463. So there's my delta x. That's how high up I go. And what it's giving me is my new value here, 5.463. And I know what you're thinking. Isn't that related to our differentials? Yes, it is. Remember, f prime of x dx. This is a differential. All right, go to the other video, and I do have a couple more runs from graphs and everything, okay? So you can take a look at those too.